everyone! So I've got these two numbers here. I've got the cube root of 3 and I've got the fourth root of 4. And I'm wondering which one of these numbers is bigger. I could just go ahead and plug these numbers into a calculator, but that's no fun. So, either the cube root of 3 is going to be less than the fourth root of 4, or it's going to be greater than the fourth root of 4. Or I guess there's one more possibility that maybe these numbers are actually somehow equal to each other. You know what? What I'm going to do is I'm going to assume that the cube root of 3 is actually equal to the fourth root of 4. Now from there, go ahead and pause this video for a little bit. Come back whenever you're ready and try and see if you can, don't go to a calculator, see if you can find out and know for sure which one of these numbers is greater than the other, or maybe somehow they're equal to each other. All right, so pause the video. When you're ready, come back. All right, so here we go. I'm going to assume that the cube root of 3 is equal to the fourth root of 4. What does that mean? Well, the cube root of 3, that's the same thing as 3 to the 1/3 power, right? So that's 3 to the 1/3 power, and that's equal to the fourth root of 4, which is 4 to the 1/4 power, right? So I'm assuming this is true, so that's going to imply that 3 to the 1/3 is equal to 4 to the 1/4. Well, I have these fractional exponents, which, what is 3 to the 1/3 power? That's what I'm trying to figure out. So I don't know what 3 to the 1/3 is. I don't know what 4 to the 1/4 is. What can I do here? How can I get rid of that fractional exponent? Well, if I multiply that 1/3 by something, that's going to eliminate that fraction, because that fraction right now is what's screwing me up. If I didn't have that fraction, if I had 3 to some whole number exponent, I could evaluate that pretty simply without a calculator. And again, I have an equation here that I'm assuming this thing is an equation. These two things are equal, so I can do whatever I want to both sides of that equation. Okay? Well, how about I raise both? I can multiply both sides of an equation by any number, right? And that's not going to change the equation. It's still going to be equal. The same goes for, I could raise both sides to some power. Well, what power? I have to do the same thing now, right? I have to do the same thing to both sides of the equation. What number can I raise both sides to that's going to eliminate my fractions? Well, right? I have a 1/3 and a 1/4. The least common multiple of 3 and 4 is 12. So what happens if I raise both sides to the 12th power? What is 3? I have 3 to the 1/3 to the 12th. So I have a exponent raised to an exponent, a power to a power. So I multiply my exponents. 1/3 times 12, that's 12/3, which is 4. So 3 to the 1/3 to the 12th, that's just 3 to the 4th. And that's going to be still equal to 4 to the 1/4 to the 12th. Again, power to a power. 1/4 times 12 is 12 over 4, 12/4, which is 3. So I have 4 to the 3rd power. Right? Follow that, right? If these things are equal, I can do the same thing, whatever I want, basically, to both sides of the equation. In this case, I'm going to raise both sides to the 12th power. So I have 3 to the 4th is equal to 4 to the 3rd. Well, what is 3 to the 4th? Well, that's 3 times 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is, I believe, 81, right? So 3 to the 4th power, that's 81. And what is 4 to the 3rd power? Well, this is still going to be equal to 4 to the 3rd power, which is 4 times 4 times 4. 4 times 4, 16. 16 times 4 is 64, yeah? So 4 to the 3rd power is 64. So, I'm assuming that the 3rd root of 3 is equal to the 4th root of 4. Well, that's going to imply that 3 to the 4th is equal to 4 to the 3rd, and that implies that 81 is equal to 64. Wait a minute, that's not true, right? 81 is not equal to 64. 81, we all know, is greater than 64. But if 81 is greater than 64, that has to imply that the 3rd root of 3 is greater than the 4th root of 4. And there we go. Pretty cool, right? And you can definitely check that in a calculator. You don't need a calculator because we know that has to be true now. But what about if we have? So here we have, right, the nth. I mean, let's say we have two numbers. In this case, 3 and 4. Let's say I just call them n and m. Just some random numbers. Let's say I have n and m. So I have n and m such that n is less than m, right? N is going to be less than m. In this case, my n is 3 and my m is 4. Then I have the nth root of n. So I have the nth root of n, and I have the mth root. I have the mth root of m. So by this here, we found out that, right, the nth root of n, in this case, 3 is our n, is going to be less than the mth root of n. In this case, our m is 4. Is this always true? Definitely I think now, go ahead, maybe try some other n and m's. Here we did 3 and 4. Try some other ones, see what you come out with. If you keep on getting that n, the nth root of n is always less than the mth root of m, we could say, hey, maybe that's always true. Could you somehow prove that? Or you find one situation where you got the mth root where n is less than n is less than m, and the nth root of n becomes greater than the mth root of m, and we say, oh, well, that's definitely not always the case. Is it always the case? I don't know. I'm going to go play around with that, and you should too. And I'll see you later. Bye-bye.